Hi guys, it's Mrs. Tucker. This is the review for Chapter 4 Functions. I want you guys to notice that your review is actually the review at the end of the book. What I did was I also came up with some specific supplemental questions to go with that review, and that's what you're going to find on this sheet of paper. So I want you to do both. So here's what I plan on doing. In this video review, I'm going to start with these pinpointed questions, and then when I've got time at the end of the day, then I'm going to go back to this review and pick out some specific questions from that to help you get ready for tomorrow's test. All right, so let's get started. Number 1 on this supplemental sheet says, Alfred has $250 in his savings account. He withdraws $25 at the end of each week. Prepare the table, the graph, and the equation or function for this relationship. Okay? At week number 0, at the very, very beginning, it hasn't gotten to the end of the first week, his account balance has $250 in it. I'm going to pause the video so you guys can finish filling out this table. Okay, so you guys have had some time to fill out this table. So, did your table look like my table? Now I have a set of ordered pairs I can graph. I'm going to come back and talk about the process in a minute, but I do now have a set of ordered pairs that I can graph. I'm going to put the number of weeks on the x-axis because the account balance, how much money he's got in his account, depends upon how many weeks he's been spending. So now I'm going to graph my ordered pairs. At week 0, he starts off with a balance of $250. Then at the end of week 1, he has $225. At the end of week 2, he has $200. Did you graph them out? Does your graph look like mine? Yes. Okay, do you guys still need some time to graph this out? Shake your head up and down if you still need some time. No, they're shaking their heads back and forth. No, they've got it graphed. Good. You know what? Even though it's not in here, you guys can tell that by the end of the 10th week, he has how much money? Yeah, let's go ahead and add that in there. I'm just going to go ahead and add that in there because that kind of completes the whole thing. He is now dead broke at the end of the 10th week. All right. Let's define our variables. The number of weeks graphed on what axis? And the account balance graphed on what axis? Okay, I need to now figure out what the process is in order to figure out what my equation is. And you guys might already know what it is. I'm just going to pick a number out of my table like 4. I want to know, what'd you do to 4 to change it into 150? That's exactly right. Jason said you multiplied it by 25, you multiplied the number of weeks by 25 and subtracted it from 250. Okay, so does that also work if I put in 5 weeks? Yes. Yeah, 5 weeks. He's taken out 5 totals of $25. That's been removed from the count, so you subtract it from 250. Does this help you write your equation? Yeah. An equation always has a what sign in it? Equal sign. So y equals what? Yeah. Did you get that for your equation? Yes. Okay. And that pops right out of your process. Everything that stays the same, those things that change, yeah. All right. Number 4 says, equation written in function notation. You guys go ahead and write me an equation. Write this equation, but write it in function notation. That means you're going to replace the y with what? F of x, yeah. Yep, that's pretty easy. That's pretty easy. Is this graph continuous or discrete, and why? I want you to explain. Discrete, why? Yeah, I did. I gave you specific weeks. It did say he withdraws the money at the end of the week, and Joe says he isn't just continually dragging money out of his account all week long. He's only taking it out at the end of the week. So yeah, this is discrete. because he only makes that withdrawal one time a week at the end of the week. What is the domain and range of this function? Use set notation. Domain. And you know what? Let's go ahead and include the 10 in here. Let's go ahead and add that 10. It just kind of feels incomplete without the 10. So if I tell you to include the 10, what's your domain and how are you going to write that using set notation? You definitely have to have a what at the beginning.
Squiggly parentheses.
The squiggly parenthesis thing, yeah. Yeah, the hard to draw bracket. And then you include all your domain numbers. How about your range?
Same thing, but with your
Yeah, same thing but with your y values. Take a look at that. You know what? I started this morning when I was writing this all up. I was going to start with 250 and then go to 225 and then go, but they usually don't do that. Set notation for domain and range is usually in numerical order. Domain and range usually doesn't show you the pairing of your x, y values. So there's your domain and range. Okay, can I continue?
Yes.
All right. Why would you use set notation instead of compound inequalities for the domain and range here? Why would you use set notation instead of compound inequalities for the domain and range?
Because it's a certain number and you're not doing like graphs.
Yes, because our graph is discrete. Yeah, you would use compound inequalities if you have a continuous graph. But because it's... Okay, I'm going to start number 7 over again. The video ended and it said I had a microphone error, so I sure hope this microphone's working now. Number 7 says, why would you use set notation instead of compound inequalities for the domain and range? Sitting here with period 5, and I picked up with number 7, so they don't know the answer because they haven't done the first 6 problems. The reason you would use set notation is because our data was discrete. Anytime your data is discrete, you're going to use set notation. Anytime your data is continuous, that's when you would use compound inequalities, okay, for your domain and range. Okay, number 8, use the function you wrote. Let's see, what function did we write? We wrote f of x equals 250 minus 25x. F of x equals 250 minus 25 times x. Use the function you wrote, find f of 12. They want you to replace the x with what number? Yeah, they want you to replace the x with a 12. So you're going to see it written like this. F of 12, what is the function evaluated when x is 12? Well, I'm going to take 250. I'm going to subtract 25 multiplied by 12. And you get what? I'm going to pull up my calculator. 25 multiplied by 12. I get, what'd you guys get?
300. Negative 50.
That's not what I got. I got negative 50.
Oh, I thought you were talking about the 25 times 12.
And if you go back, I know these guys haven't looked at the problem, but if you go back, you guys are going to find out that he's either incredibly in debt to somebody or this range value isn't going to work. We picked a domain value that didn't make any sense. Okay? It says, what is your dependent variable and why? Well, we always graph the dependent variable on the what axis? On the y-axis. So if I go back and look at this, what variable got graphed on the y-axis? Yeah, the account balance. So our dependent variable is the account balance. Because the balance in my account, or in his account, depends upon how many weeks he's been withdrawing money. The account balance depends on how many weeks he withdrew money. Why does this situation only graph in quadrant 1? Okay, I'm going to go back and look at the graph. You know, if I had a full coordinate grid, it would look like this. Why does this graph only graph in quadrant 1? Because number of weeks cannot be what? It can't be negative. Now, an account balance can be negative if you're overdrawn. But we're going to say this kid, Alfred, when he gets to 0, he has no more money and he can't withdraw anymore. So we're going to say his account balance can't be 0 also. That's why this graph only graphs in quadrant 1. Thanks. All right. Mapping diagrams. Is this mapping a relation? What's a relation? It's not just a group of numbers, it's a group of what? Yeah. A relation is a group of ordered pairs. Do we have ordered pairs here? Yeah, I could write -3, comma 1. I could write -2, comma what? 5. I could write 2, comma 5, and I could write some more. Is it a relation? Yes. Now, is it a function? You're saying yes. Why?
Because there's no repeating numbers on the x-axis.
None of the x values repeat. And do you see that each one, bless you. Do you see each one of these x values? Oh, and right here, they didn't label these ovals. You have to assume that's x and that's y. Each one of these x values only has one arrow coming out of it. Does it matter that 5 has 2 arrows coming at it? Does it matter that 1 has 2 arrows coming at it?
No.
Does it matter if 7 has 2 arrows coming at it? No, it doesn't matter. What matters in a function is each x only gets paired with one y. So is it a function? Yes. Because each x is paired with only one y. Okay? Look at this one down here, number 12. Is this mapping a relation? Yes, why?
Because there's ordered pairs.
Because I could write ordered pairs. Yes, it is a relation. So that's definitely yes. Because I can write ordered pairs. Is it a function?
No.
Why not?
Because there's more than one function per number. Or like more than one number on the x value. Then there needs like there's 2 ordered pairs on the x value has more than one pair.
Yeah, take a look at this x value of -1. X value of -1 gets paired with -4, and x value of 1 also gets paired with what? 2. And repeating your x values like that isn't allowed in a function. So this x is getting paired with 2 different y values. That's not allowed in a function. So nope, it is not a function because the x isn't paired with one unique y value. This x of -1 is paired with 2 different y values. My x value of 1 is being paired with 2 different y values. I'm so proud of you guys that you didn't say anything about husbands, wives, sheiks, or harem girls. Thank you. Because I don't want to see that on the test. All right. Number 3. Name the quadrant that point Q is located in if x is greater than 0 and y is less than 0. I'm going to pause the video and give you guys a moment to think about this. Okay, these guys have had time to think about it. First, I asked them, do you know the names of the quadrants? And they all did. They said, that's quadrant 1. Here's quadrant 2, here's quadrant 3, here's quadrant 4. Sometimes you see them in Roman numerals. I hope you guys all learned your Roman numerals, at least up to 4. Okay, x is greater than 0. From the origin, isn't these your x values greater than 0?
Yeah.
Going in this direction.
Yes.
Okay? Then it says y is less than 0. Start at the origin. Going downwards, aren't these y values less than 0?
Yes.
So point Q falls in which quadrant? Quadrant 4, that's right. Quadrant 4. Okay, so you were so smart on that one. We'll have another one of those in a minute. Here's number 14. What is G of 4?
Oh, can I answer it?
Well, I want y'all to answer it. Write it down on your paper. Here's the function g of x. See that straight line? They're calling that function g. They want to know, when they write it this way, what are they asking for? The y value when what?
When x is 4.
That's exactly right. They want to know what is y when x equals 4. That's exactly what they're asking for. I saw one of those on the EOC a couple years ago. I had my fingers crossed that the kids knew what that meant. You guys are going to know what it means. So I'm going to come in at an x value of 4. I'm going to go up to my line, and what's my y value? Yeah, I'm going to come up, go over. So g of 4 equals what? 8. Yeah. Yeah. It's that easy. You just have to know what they're talking about. Okay, 15. Given the function h of x equals 3x minus 4, find x if f of x equals 17. Oh my gosh, I saw one of these on the EOC also. Had my fingers crossed. H of x is a fancy name for what? No, it's a fancy name for what? Y. Y equals 17. If y equals 17, let's put in a big fat 17 right here. They want to know what's x. Do you guys see where we're replacing the h of x with 17? If h of x is also known as 17, we're going to put 17 right there. We're solving 17 equals 3x minus 4. And I know you guys know how to do that. Add 4, divide both sides by 3. What do you get?
7.
X equals 7. Yep.
Yay, we're smart.
Okay, I'm going to pick up with number 16 at the end of the day. So any of you guys joining me for tutoring after school, we're going to start with number 16. Will you remind me of that?
Yeah.
All right. Okay, number 16. Let me see if I can get this thing to go away. If f of x equals 5x minus 3, state the range if the domain is -1, 0, 2, and 5. Yeah, that's easy. What are we going to do? We're just going to plug in those numbers. Let's put in a -1. I'm going to take 5, multiply by whatever my domain value is, and subtract 3. So let's plug in -1. 5 times -1 is? -5. And -5 subtract 3 is? -8. You know what? I'm going to write it out here because I'm going to turn around later and put them in numerical order. Let's put in a 0. Pop in a 0 right there. You know what? This is going to be a numerical order, isn't it? 0 times 5 is 0. What's 0 subtract 3? -3. Let's put in 2. 2 times 5 is 10. 10 subtract 3 is 7. And then let's take that out and pop in a 5. 5 times 5 minus 3 is 22. Yeah. And we've got this in set notation. I think I would just add that in the front so we know it's the range. Okay? We're good on that one. 17. Name the quadrant on which point B is located when x is less than 0 and y is greater than 0. Okay, this is quadrant 1, 2, quadrant 3, quadrant 4. All right. We're going to start at the origin. On which side of the origin, the left or the right, are your x values less than 0? Yep, this way your x values are less than 0. If I start at the origin, do I go up or down if my y values are greater than 0? Up. And the intersection of those two is quadrant what? Yeah, so point B is going to land in here somewhere. Yeah, so the answer to this one's quadrant 2. Okay. 18. Which equation matches the function listed in the table? I have y equals 30 divided by x, y equals 3x plus 5, y equals x squared plus 6, y equals 0.5 times x minus 3. Look at all these x values. Look at these spots where I could plug in an x. That's exactly what we're going to do. I'm going to pick an x value out of the table. For instance, like 0. I love 0. It makes your math easy. I'm going to plug it into each one of these and see which one of them gives me a back y of 5. If I put in 0, well, first of all, I can't divide by 0, can I? You're not allowed to divide by 0. I don't think it's a. Let's put in 0 for x right here. 3 times 0 is what? 0 plus 5 gives you what? It could possibly be that one. But it could also possibly be other, so you need to check it out. Put in 0 here. What's 0 squared? 0. 0 plus 6? Okay, that equals 6. I don't think it's that one. 1/2 times 0 is 0, and 0 minus 3 is? I don't think it's that one either. And you know what I think I'd do? Just as a double check to make sure I did my math right, I'm going to pick one more number. I'm going to pick something, I'm going to pick this one right here. Put in 2. Well, 30 divided by 2 is 15, not 11. No, it's not that one. Put in a 2. 2 times 3 is 6, plus 5 more is 11. That checks out. 2, right here, 2 squared is 4. 4 plus 6 is 10. Nope. They say it's 11. Can't be that one. 1/2 multiplied by 2. 1/2 of 2 is 1. 1 subtract 3 is -2. They say the answer is 11. I'm feeling pretty good. My answer is what? B. Yep. Yep. All of these, when you put in all of these x values, for instance, like this one, 3 times 4 is 12, plus 5 more is 17. You're always going to get back that y value. Number 19, which equation matches the function listed in the table? What? Isn't that exactly the same as 18? Oh, the numbers are different. Do the same thing. Pick you a number. 1 is easy, but 1 is tricky. 1 could make 2 of those equations correct. You got to be careful with the number 1. 30 divided by 1 is 30. They say the answer is 7. Let's put in 1 for x right here. 3 times 1 is 3, plus 5 more is 8. They say the answer is 7. Let's put in a 1 right here. 1 squared is 1 times 1, which is 1, and 1 plus 6 equals 7. I'm liking that. 1/2 times 1, or 0.5 times 1 is 0.5. Subtract 3 is -2.5. I'm thinking the answer is C. I'm going to try one more. I'm going to use 2. 2 squared, 2 times 2 is 4. 4 plus 6 is 10. Yep, our answer here is C. Did you girls get C? All right. Number 20. Which equation is represented by the graph below? Ooh, this one's tricky. This one's so tricky. You know what? I wished I had a set of ordered pairs just like we did in the last problem. So I could pick the x values, substitute them in, and see if I get back the y values. Could you use this graph and generate a couple of ordered pairs? Yeah, definitely right here. What's the name of that ordered pair? Oh, be careful. Do your x first. 3, 0. Could I generate one other additional ordered pair by using this point here? What's the name for that point there? 0, 9. Okay. Now we can test it out. I'm going to use 0 first. I love using 0. It makes the math easy. Plug in a 0 for x in each one of these. Do the math, see if you get back a y of 9. Zero times 2 is 0. 10 subtract 0 is 10. They say the answer is 9. I don't think it's A. B, 2 times x. Well, let's take 2 times 0. That's 0 plus 3. That gives you 3. No, they say the answer is 9. Let's put in 0 right here. 3 times 0 is 0. 9 subtract 0 is 9. Ooh, I like that answer. Let's check it out here. 0 times 3 is 0 plus 2 is 2. Just to make sure I did my math right, I'm going to plug in a 3 right here. If I put in 3 for x right here, I've got 3 times 3, which is 9, and 9 subtract 9 is 0. Yeah, our answer is C. I like that. That was a good question. I don't think we've seen anything like that yet in our homework, have we? No. I like that question. Uh, 21, we're going to do the exact same thing. Which equation is represented by the graph below? I wished I had some ordered pairs. I can name that ordered pair right there. What's the name of that ordered pair? 0, 1. I'm going to test that one out and see what I get. If I put in a 0 for x, 0 times 0 is 0, plus 2 equals 2, they say the answer is 1. Let's put in a 0 for x right here. 3 times 0 is 0, plus 2 equals 2. They say the answer is 1. Nope. Let's put in a 0 right here. 2 times 0 is 0, plus 1 equals 1. That one works out. Let's put in 0 for x down here. 0 times 0, I'm going to take 2 times 0 squared plus 1. 0 times 0 is 0. 0 times 2 is 0. 0 plus 1 equals 1. Do you guys see why you have to check it out with each one of the answers? Because 0 gave me back a 1 for both C and D. Don't stop at C and pick that as your answer. That might not be your answer. I've got to see if I can't pick another point off the graph. So I'm going to do this. I'm going to come in here at 1. Let me get a skinnier line than that. Skinnier line. Let's see if I'm able to do that. Hold on a minute. I don't know. It looks like an x value of 1 might give you back a y value of what? It looks like 3. 1, 3. If I put in a 1 right here, 2 times 1 is 2 plus 1 is 3. That seems to work out. Let's try down here. 2 times 1 squared plus 1 equals what? 1 times 1 is 1, times 2 is 2, plus 1 is 3. Oh my gosh, it still works out. That's not helping me out, is it? Let's go try this one right here. It looks like it crosses at an answer of about what? I'd say it's a little lower than that. I think it looks like it's about what? Let's try that out. Let's put in a 2. 2 times 2 is what? think the answer's 9. That's 4. 4 plus 1 is?
Tucker, I'm doing tutoring tomorrow if any of your kids. When are you testing tomorrow?
I'm thinking it's not C. Let's test it out in D. Let's put in a 2 for x. 2 times 2 squared plus 1. You're going to do your exponent first. 2 times 2 is 4. 4 times 2 is 8. 8 plus 1 equals, oh my gosh, look at how many times we had to test this out before we found the right answer. Woo! Okay. Okay, here is the answer bank, scrambled answer bank, I think that goes with all of this supplemental review. So I think what I'm going to do now is send this up to YouTube real quick, and then I'm going to pick out some questions out of your textbook, the end of chapter 4, and let's look at some of those. Okay, guys, this is the end of chapter 4 study guide review at the back of the book. The thing I really like about the reviews at the end of the back of the book, besides the fact that all the answers, not at the back of the book, at the end of the chapters, the thing I like about the reviews at the end of the chapters is all the answers are where? In the back of the book. The other thing I like about the textbook reviews is they give you some examples over here on the side, and then they ask you some questions that are similar to the examples. So this is on page 280, and I assigned all the evens. So let's just start working some. This one here was graphing relationships. On number 4, it said sketch the graph for each situation. Tell whether the graph is continuous or discrete. Okay, I don't have a lot of white space here. I'm just going to, I'll sketch a little graph in this section right here. It says, a girl is walking home at a steady pace. Ooh, this sounds kind of like our CBR thing. Girl's walking home at a steady pace. Then she stopped to talk to a friend. After her friend left, she jogged the rest of the way home. So this is going to be time in, I don't know if it's seconds or minutes, and this is going to be distance. And is this distance, I guess this is distance from where she's at to home. Distance from where she's at to home. So at time equals 0, when she's walking at a steady pace, is she increasing or decreasing the distance from where she's at to home? If she's walking home, she's decreasing, and she's going at a steady pace. So that means the line's got to be pretty, let me do the line. She's walking at a steady pace, so the line's going to be straight, like that. Then she stopped to talk to a friend. What happens to our line? Horizontal. And then she jogs the rest of the way home. So she's still decreasing her distance between home and where she's at, but how should this line compare to the original drop right here? It should be faster. So is that going to be less steep or more steep? Yeah, more steep. It should look something like that. Okay, number 6. Jason was on the 2nd floor when he got a... Oh, it is continuous. I'm sorry, you're right. They wanted to know if it was continuous or discrete.
Would all of those kind of graphs be continuous?
Not necessarily. Question is, would all of the graphs be continuous? It's not necessarily always going to be continuous. Let's look at the next one. Jason was on the 2nd floor when he got a call to attend a meeting on the 6th floor. Okay, so I'm thinking we need to change distance to what? To the floor he was on. Yeah. Jason was on the 2nd floor when he got a call. Was on the 2nd floor when he got a call to attend a meeting on the 6th floor. Then he took the stairs. After the meeting, he took the elevator to the 1st floor. Okay, so I'm thinking he started off where? So probably right about here, 2nd floor. He was on the 2nd floor. He got a call to attend a meeting. He's going to take the stairs up to the 6th floor. up to here. Is he going to get up there fast, or is he going to go kind of slow? Kind of slow, because he's taking the stairs. The whole time, the floor where he's at is going to be increasing, and it's going to be increasing the whole time he's getting up to the 6th floor. He took the stairs after the meeting, so this is going to stay level during the meeting because he's still on the 6th floor. After the meeting, he took the elevator to the 1st floor. So how should this line look when he goes down to the 1st floor? Yeah, it's going to be very straight until or not straight, but very steep till he gets to the 1st floor. Something like that. Okay? Continuous or discrete? Yeah, that's continuous. Number 8, they want you to write a possible situation for that graph. We're doing time versus height. Time versus height. Can you think of a situation? We're going to pause the video here. Okay, so me and my girls, we came up with a situation we really like. Here you're taking a swing down in the height, but it swings back up and then it stays level. We all thought this looked like a boy at a skateboard. It could be a girl. It could be one of you girls at the skateboard park. You're on this side. You skate down the, I don't even know what it's called. The ramp. The half pipe. I don't know what it's called. You get to the top and then you stay at the top, right? I don't know what it's called. I'm not a skateboarder. All right, let's go look at number 10. I know what it's called. We're going to have to figure out what that's called. I'm sure the guys are going to come in tomorrow and tell me what that's called. What's it called? Half pipe? Okay. Okay. Well, that's what I said. All right, 4-2, number 10. Express each relation as a table, as a graph, and as a mapping diagram. Do I need graph paper? Yes. Okay, we're going to express number 10 as a table. It's an XY table. I can do better than that. My X values, my Y values, -2, -1, -1, 1, 2, 3, and 3, 4. There's my table. Can you graph it? You guys are going to get out graph paper and you're not going to do what I'm about to do. I don't have any graph paper. I'm going to estimate. -2, -1. -1, 1. 2, 3, and 3, 4. And it probably, I'm guessing, falls on a straight line. But my girls here, they're graphing it. They're going to tell me, does it fall on a straight line? No. No? It's not straight? Okay. You know, you guys could put this in your graphing calculator and look and see if it comes out to be a straight line. Of course, if it's on a test and you're supposed to graph, you better graph it for me because I can't see your calculator. They want it as a mapping diagram. So let's make a mapping diagram. Here's my X values. Here's my Y. If any repeat, you don't repeat them. -2, -1, 2, and 3. I have -1, 1, 3, and 4. And we're going to map this out. That goes to that. That goes to that. That goes to that. That one goes to that one. I'm going to ask you guys, is this a function? Yes? How do you know? Yeah, each X value is paired with exactly one Y value. Yep, you can see it here. You can see it up here. You can tell from a graph. How can you tell from a graph if it's a function? Good. It will pass the vertical line test. Yeah. Okay, on number 12, give the domain and range of each relation. All right, number 12. The domain is all of your X values. And because it's given to you as discrete points, you're going to use set notation and these pretty little curly brackets. My domain values, -2, -1, 0, 1, and 2. My range, -1, 0. Do you guys see how -1 repeats itself? There, and there. You're not going to repeat it in your range. So I'm just going to put in -1, comma 0. And we're done with 12. That was number 12. Okay, let's look at 14. On number 14, and I think what I need to do too at the end of this video, and maybe I'll do it right now, is show you guys all of the answers to the cut and paste that you guys put in your journals, because I don't think we ever went over that. I'll show you all the answers. All right, let's do our domain for number 14. Is it continuous or discrete? It's continuous. So if it's continuous, it's going to look like a compound inequality. So I'm going to take a piece of paper and move it so it just touches this end and it just touches this end. Oh, I can do better than that. Let me try again. All right. And it looks like there were closed dots. So all of my x values fall between here and here on the graph. On the low end, what's my low number? -4. And on the high end, my high number is what? 3. And because it's closed dots, let me move these away and I'll show you. It's closed dots. What symbols do I put in between? Yeah, less than or equal to and less than, okay. So x is greater than or equal to -4, but at the same time less than or equal to 3. You guys do the range. Those will be your y values. Oh, it just touches there. And just touches there. All of these y values between here and here are being used. On the low end, it goes down to what? -3, yep. And on the high end, it goes up to what? 5. And I'm going to move these away. I have closed dots. We are going to have to assume that this is a what dot right here? We're going to assume that that's closed. If they didn't want us to include it, they would definitely have made that an open circle. So we're going to put in this. All of my y values are greater than or equal to -3 somewhere on this graph, but less than or equal to 5. So that's our answer to number 14, right there. I'm going to ask you another question about 14. Is 14 a function? Yes? How do you know? Yes, it does. It passes the vertical line test. Good for you. Vertical line test, the vertical line will only pass through the graph once every time I move it. All right, let's look at 16. Give the domain and range of each relation and tell whether the relation is a function. Explain. Okay, on 16, domain is discrete here. -4, -2, 0, and 2. My range, there's just 2 numbers in my range. Okay, that's the easy part. Tell whether the relation is a function. Is this relation a function? Why is it a function? Yeah, each of these x values is only paired with one y value. Does it matter that the y values get more than one x value? No, that doesn't matter. If you graph this, it will pass the vertical line test. Number 18. A local garage charges $5 for the first hour plus $1.50 for each additional hour or part of an hour. You know, so if you're only in the garage for like an hour and a half, they're still going to charge you like you were in there for 2 hours. Write a relation as a set of ordered pairs in which the x values represent the number of hours and the y values represent the cost for x hours. Use a domain of 1, 2, 3, 4, and 5. Is the relation a function? Explain. They want us to do a lot. Okay. Here's my x values, here's my y values. They want us to use a domain of 1, 2, 3, 4, and 5. Can you guys write the equation that represents the cost? They charge you what? $5 for the first hour plus $1.50 for each additional hour or part of an hour. Would this be right to write it like that? Because for the first hour, they're going to charge you $5. But if you put in 1, your charge isn't $5, it's $6.50. Yeah, it doesn't count for the first hour. This is like that question on the Chapter 2 test. We have to take this and subtract what right here? 1. Yeah, we have to subtract out that first hour because the first hour is being charged at this for